Section 5.6, defining sequences recursively. We've seen a little bit of this before, but by recursively, we mean that we are using one or more of the previous terms so that we can then figure out what the next one is. So, this is certainly one way that we can write a formula. This would be an explicit formula, but that is not the recursive way. So again, a recursive, we are going to be given at least one initial condition, and then our formula will refer to one or more of the previous terms. So let's see an example. C0 is 1, C1 is 2, and here's my recurrence. C of k is C of k minus 1 plus k times C of k minus 2 plus 1. So let's say we want to find C sub 2. That means it's going to be C1 plus 2 C0 plus 1. Again, our k value there is 2. That's where that 2 is coming from. And then I can compute that and get 5. Similarly, to find C3, it's going to be C2 plus 3C1 plus 1. I get 12. And similarly, I can get my C4 value as well. So sometimes we want to have more than one way to write the same thing. So for example, we could have k greater than or equal to 1, and we're looking for s sub k. We could also have k greater than or equal to 0, at which point we're looking for s of k plus 1. And you'll notice my notation on the right-hand side changes accordingly as well. So again, there's more than one way we can express these things. So let's find some sequences that satisfy the same relation. So I've got my A sequence and my B sequence, and A1 is 1, A1 is 2, B1 is 1, AK is 3 times A sub k minus 1, BK is 3 times B sub k minus 1. And let's find the second, third, and fourth terms for each of those. So here we've got written out, I get A2 is 6, A3 is 18, A4 is 54, B2 is 3, B3 is 9, and B4 is 27. And again, we could then also write those as the first few terms, and then comma, dot, dot, dot if we wanted to. Another common sequence are called the Catalan numbers, named for a particular mathematician. Here is our formula. I'm actually going to skip this because, but since this includes that choose that we skipped, I am not going to worry about that. You will not see any problems like that in the homework, but you can see those values there if you would like to see them. Let's look at a recursively defined sequence. That's what I'm going to care more about. Here's a picture. And let's talk about the Fibonacci numbers named after Fibonacci. And these are based on how rabbits multiply as they have babies. So I'm going to pretty much jump into the solution here. You can kind of see a discussion of where these numbers are coming from. But we are going to set it up with f0 is 1, and f1 is also 1. And we are going to define the k term as the sum of the two previous terms. So our first few Fibonacci numbers, again, we had 1 and 1, and then 2, 3, 5, 8, 13, 21, and so on. And that is a very common sequence. Here's a few more terms as well. I believe you will have at least a few examples in your homework where you will have to deal with Fibonacci numbers. So again, here is how we define them.